Here we are going to cover a few Java programming performance tips. So we'll cover strings, collections, exception handling, primitive versus object, and system array copy. Strings. So when you have a choice of using string versus string buffer, you want to use a string buffer whenever you need to manipulate the string. So string objects are immutable, which means that when you concatenate two strings, that means they have to destroy those two string objects and they have to recreate a brand new one. Okay. So string concatenation creates a multiple intermediate representation, which is costly from performance perspective. So you want to use a string buffer class, which is mutable. Okay, so for any string manipulation, you want to use a string buffer. String literal versus a string object. So string literals are unique. So there is only one copy of each unique string. So in this case, the first S1 and S2 is actually pointing to the same hello object. S1, S2 right here. However, string objects, when you create the string object with using a new keyword, then it's actually creating a brand new string object like this. Okay. So from memory usage perspective, you want to use a single the string literal whenever possible. Other string related tips. Using character array, char array is more efficient than using string object for character access and manipulation. Use length whenever you need to compare two strings instead of using equals. Okay, especially when the chance that those two strings lengths are different, you want to actually compare length instead of using equals. When strings are compared, when strings that are compared have equal length, then you want to make sure you want to use a case-sensitive comparison because that's a bit faster rather than case-insensitive comparison. Of course, when you need to compare case-insensitive, you have to use case-insensitive. But when the case-sensitive comparison is okay, then you want to use it. When strings that are compared have a different length, case-sensitive comparison is faster, but not that much. So in that case, you want to use length first, and then you want to use the case sensitive after that if they are the same length or something like that. Okay, so exercise 1. So let's import all the Maven projects. So they are all Maven project. Import existing Maven project. And then exercise 1, we are going to try with the string buffer, and string literal versus string object, string versus char array, equals length. So we're going to actually try different usage and compare the performance. Yeah, it's taking its time. So only thing you have to do is basically right click the project and run as and Java application, and then you select the main class, and then you are going to see the result. Okay, so when you're using string, it's taking 39 milliseconds, while string buffer takes about 1 millisecond. So you see the performance difference between the two. Okay, so if you take a look at the code, so here in this case, basically, this is usage of string, and this is usage of string buffer. So here we are just adding hello Mr. Someone and hello Mr. Someone. So here we are using string buffer, just append. Okay, this one using a string. So this is taking a lot longer than string buffer. Okay, and string literal versus string object. So here, yeah. So basically we are just the capture the duration of this operation. Okay, so this one is using string literal, so you're using string literal of hello one and world, and here we are just creating a brand new string object each time. Okay, and that is 10 millisecond versus 40 millisecond. So let's just import, and I'm gonna just run just one. And the string versus char array. So string takes 12 millisecond and char array take 4 millisecond. Okay, and this one is equals versus length. So again, 24 versus 3, and equals ignore case equals. Okay, all right. So let's I'm still importing it. Alright, so I'm going to let you guys actually do the work. Okay, so it's pretty straightforward. So I'm going to give you about 10 minutes to try exercise 1. Let's move on to collections. So there are a few collection classes that you can use, array list versus linked list. Okay, because the way that they are constructed, you know, depending on what operation you're actually performing, different performance result will occur. So for insertion at a particular point, linked list has a huge performance advantage over array list, because linked list, because it's linked in, you know, you can actually go to a particular location and then just change the link. Okay, while array list, you probably have to actually move a lot of the entries, okay, to accommodate the newly entered item. Okay, for sequential access, array list performs better than linked list, and for random access, however, array list has so random access, array list has a huge performance advantage over linked list, because array list, you know, you can go directly to that particular entry, while the linked list you have to go through the chain. Okay, let's see. Collection classes versus vector and hash tables. So vector and hash tables are not used anymore, so it's probably a moot point. Okay, so vector and hash tables synchronize on all methods, while array list, linked list, hash list, and hash map, they are not synchronized. If you need the synchronized the array list or linked list, then you can use a wrapper like collection synchronized list, you know, something like this. Okay. Okay, so let's do exercise 2. Exercise 2 is collection. So here we are gonna compare array list versus linked list. So let's try. I'm gonna just try just one of this, and then I'm gonna explain it. Array list versus linked list. Array list versus linked list for insertion. Okay, so let's run this guy. Okay, so using array list for insertion takes 21 millisecond, and the linked list takes only 7 milliseconds. So linked list definitely has an advantage for insertion. Okay. Array list and linked list for sequential access and random access, and then vector. Okay, so again, synchronized versus unsynchronized. Again, nobody's using vector these days, so you know, if you want to skip 4, 5, 6, that's perfectly fine. Okay, so I'm going to give you guys 5 minutes to try this exercise 2. Exception handling. Exception handling could be pretty expensive. Okay, so you know, you certainly need to use exception handling to handle unexpected conditions. Okay, but you do not want to use exceptions just because it's possible. Okay, so when you do need, you know, use exceptions only when you need to use it. If normal programming logic can suffice, then you want to use the normal programming logic rather than using exceptions. So let me give you an example of that. So suppose if you want to check out of exception bounds, okay? So in this case, we checked exception bounds using a logic here. Okay, and here we are using index out of bounds exception, and this is a lot more expensive than this. Okay. All right, so let's do exception handling. So you can see throwing an exception takes 77 milliseconds, while using business logic is only take 1 millisecond. Okay, so if you see the logic, the one is actually using the business logic, and the other one is using an exception. Okay, so you do not want to use exception when a business logic handling suffices your need. Okay, and handle exceptions. Yeah, so this is the what is it? Yeah, cause exception. Yes, in null case. Okay, this one is the out of bounds exception. Okay, so again, the 62 millisecond versus 1 millisecond, a huge difference. Okay, so let me see whether that is going to be the result in my case. Exception. Okay, so oh wow, in this case 466 millisecond versus 0 millisecond. Okay, so it's even more dramatic. Alright, so I'll give you guys 2 minutes to try this exercise. Okay, so let's move forward. Primitives versus object. So primitive int performs much faster than integer object. Okay. Autoboxing is available from JDK5, but you do not want to use autoboxing just because it's available. Autoboxing could be expensive. Okay, use casting sparingly. So casting or autoboxing, they could be more expensive. So let's do exercise 4, primitive. So here we are using the primitive, and here you are using integer object. Okay. So when you run it, in my case, it's actually 62 versus 11 millisecond. Okay, and this is autoboxing. So oh yeah, this is I did just autoboxing. So the first one is what? Autoboxing. What is this same thing? Java performance autoboxing. Looks like they actually. Oh, okay, yeah. So this one is not really autoboxing. This is actually incorrect. Java performance. It should be primitive versus. Yeah. So this one. Yeah. So the documentation is wrong. So run as and Java application. And yeah, so it's 24 times 153. Okay, so primitive is definitely faster, and autoboxing we just did it. Autoboxing. Okay, and the last one is casting. Yeah, so casting again, there is a performance difference. Okay, so I'll let you guys do this lab, and I'll give you a few minutes. The last one is copying. So when you need to copy things, you might want to consider to use system.arrayCopy native function, because it's a lot more efficient, because it's actually very much optimized. Okay, so that is the last exercise. So I just run system copying here. So without using system copying, it's taking it took 103 milliseconds. Using system.array copy takes 3 milliseconds. So obviously there is a huge performance difference. Okay, so if you take a look at the code, this is our own way of copying things. Instead, we can use the array copy. Okay, and that should be a lot faster. Alright, so that is the end of